There are two types of circuits we will study in this class, series and parallel circuit. The circuit on the left is a series circuit. This type of circuit has a single path for current to flow. The second circuit is called a parallel circuit, and it has more than one path for current. At the top of the circuit, the current coming out of the voltage source splits into two directions. One current goes to the left and the other goes down into the first branch. In this presentation, we will focus on the first type of circuit, the series circuit. The current throughout a series circuit does not change, but as the electrons flow through the components in a series circuit, energy is released and there is a voltage drop. The circuit on the right consists of a battery connected in series to two light bulbs. The current in the first light bulb is the same as the current in the second. When the switch in this circuit is closed, the circuit is complete and the current is able to flow. Here is a series circuit with an ammeter placed on the top to measure current. The zigzag symbols represent something in the circuit that is converting electrical energy to another form of energy and causing the voltage to drop. The total current coming from the source is equal to the current going through each resistor. The way to say this is that I total equals I1 equals I2 equals I3, etc. The total current moving through a series circuit is determined by the size of the voltage source and the total resistance. You can find the total resistance in this type of circuit by adding up all the individual resistances. In this case, 4 plus 2 is 6 ohms. The source voltage in a series circuit is equal to the sum of the voltage drops in the resistors. We can also find the total voltage using the total current and Ohm's law, R equals V over I. Since we know the total current and the total resistance, we can use Ohm's law to find the total current. When we divide both sides of the equation by 6 ohms, we get a current of 3.3 amps. Since there is only a single current in a series circuit, the total current coming out of the source is equal to the current going through both resistors. In a series circuit, the current coming out of the source is equal to the current going through each resistor. The total resistance in a series circuit is equal to the sum of all the resistors in the circuit. The total resistance in the circuit in front of you is 6 ohms. The source voltage is the algebraic sum of all the voltage drops caused by the two resistors. So the sum of the voltage drops for the circuit in front of you must equal 20 volts.